Hello everyone, welcome to Driven Maths and Physics. Thank you so much for tuning in today. In today's lesson, we're going to look at centripetal force and centripetal acceleration. These are very unique concepts that we're going to make sure that you really understand and are able to visualize them. And that's what we're going to do in this lesson. And we'll do some examples at the end. Yeah, this is going to be fun. Okay, so first of all, let us understand something. We'll start by defining the centripetal force. Okay. What I want you to understand is that normally, according to the first law of motion, Newton's first law of motion, is that if an object is moving with a certain constant velocity, okay, if it's moving in this direction, what we expect is that that object will continue to move in a straight line. Okay, in a straight line. Okay, in a straight line, unless an external force, okay, unless an external force causes it to behave differently, unless an external force causes it or compels it to behave differently, what we expect is that that object continues in the straight path. But if it is going to change its course of movement, it has to be because an external force was applied that caused its behavior to change. Okay, that's the first law of motion. And this is what brings us to the centripetal force. The centripetal force is the force required, okay, look here, it's the force required to keep an object in a circular path. Okay, normally and naturally, an object, if it is moving, will move in a straight line. So if it's going to move in a circular path, you have to compel it to do so. There has to be a force that is constantly acting on the object to keep it moving in a circular path. That is very important for you to understand. Okay, that's what the centripetal force is. It's a force required to keep an object in a circular path. Force required to keep an object in a circular path. That's all it does. It keeps the object in the circular path. It does not really cause the motion, but it just keeps the object in the circular path. That means if you remove the centripetal force, the object will once again go back to moving in a straight line. Okay, so now here, this point is very important. Centripetal force is the force that causes an object that's moving in a straight line to start moving in a circular motion. So an object that is moving in a straight line, for it to start moving in a circular motion, there has to be a centripetal force present. Okay, the other thing I want you to understand is that centripetal force is not a type of force per se. Okay, it's simply any force that causes an object, that keeps an object in a circular path. But it can be friction. Okay, it can be tension, it can be a normal force. Okay, it can be so many other types of forces, as long as if at that point what is keeping the object in a circular path is tension, then the centripetal force will be tension. If at that point it is friction that is keeping an object in a circular path, then that friction will be the centripetal force. If it's the normal force keeping the object in a circular path, then the normal force will be labeled as a centripetal force. This is very important for you to understand. Okay, it's not a type of force, it's simply any force that keeps an object in a circular path. Now, factors affecting the centripetal force, we're right here. Okay, pay attention to this. It says you have to understand that more centripetal force will be needed if mass of an object is increased. Is this true? Come to think about it. Which one is easier to keep in a circular path, a light object or a heavy object? Imagine a bowling ball moving, okay, and you want to start to cause it to move in a circular path via a string. Okay, and let's take, you have tied a cow, okay, a cattle, all right, via a rope, and then you're holding on to the rope that is tied around the neck of the cow. Okay, and the cow is moving in a straight line, and you want to compel it to move in a circular motion. Where will it be easier, the bowling ball or the cow? One of the reasons why it will be harder with the cow is because the cow is a heavier object. And so for you to keep it in a circular path, it takes more force. Okay, so here they're saying more centripetal force is needed if mass of the object is increased. In other words, centripetal force is directly proportional to the mass of the object. The greater the mass of the object, the more centripetal force you will need to keep that object in a circular path. Agreed? Okay, so what we're seeing here, first of all, is the centripetal force, which is F, and subscript C is directly proportional to the object's mass. Okay, then we're saying here that more centripetal force, point number 2, more centripetal force is needed if speed of object is increased. Okay, which one is easier to keep in a circular path? An object moving slowly or an object moving fast? Okay, a fast moving object will be harder to keep in a circular path. For you to manage to do that, you have to apply more centripetal force. So once again, we see a direct relationship between centripetal force and the velocity of an object. Okay, the velocity of an object. Now, the other part is they're saying more centripetal force, the third point, is needed if radius of a circular path is reduced. If radius is reduced, more centripetal force is needed. Okay, so I think to explain this, the easiest way would be to use a door. Okay, a door. So let's take, we have a door. Let's take, we have a door. Okay, sorry about that. So if we have a door, it's an entrance to something, and there is a door handle right here. Okay, a door handle. All right, so if this door is going to move, it rotates that way. Okay, it rotates that way, and you see it until it hits this part and the door is closed. Okay, so there is a circular motion that is supposed to happen to and fro, a circular motion that is supposed to happen. But now my question for you is, which one is easier? Because if it's moving like that, it means the radius of the circular path will be this one. Okay, it will be from the door handle to the hinges. Okay, so which one will be easier, to close this door when the radius is bigger, or when the door handle is here, right here, close to the hinges? Which one will be easier, when the radius is small or when the radius is bigger? What you will notice is that you will need more force when the radius is small. But when the radius is bigger, like this, closer to the edge of the door, what you will notice is you don't need as much force to cause the object to move in a circular path. Does that make sense? So this tells us that the centripetal force has an inverse relationship with the radius of the circular path. Okay, so is inversely proportional to the radius. All right, now keep those ideas in mind. Let's transition to the next thing. Okay, now look here. Okay, what I want you to see is that, first of all, the force required to keep an object in a circular path. Well, we've established this in the previous slide. We said the force required here to keep an object in a circular path, that's what we call centripetal force, is directly proportional to the object's mass. I think we did this. We said the centripetal force is directly proportional to the object's mass, and they're saying to the square of its velocity. Okay, and then also to the inverse of the radius of the circular path. Remember, it had an inverse relationship with the radius. Okay, now someone may ask, why are they saying the square of the velocity? It's still a direct relationship as we established in the previous slide, but the reason why they're saying a square is because there is an exponential relationship between the velocity and the centripetal force. That means the increase is rapid. Okay, it's rapid. Now that's what I want you to understand. So whether it's a square of velocity or just velocity, what you need to know is that the greater the velocity of the object, the more force you will need to keep it in a circular path. This gives us a formula for centripetal force. So this means mass times v squared over r. Okay, and then if we change that to equal sign, there will be a constant, mv squared over r, where k is a proportionality constant, which is equal to 1. Therefore, centripetal force will be equal to equal to mv squared over r. That is the formula for centripetal force. All right, this is very important. Okay.